Hello everyone, welcome back to a new video. Today I'm going to be solving some questions on A-level trigonometry and transformation of functions. Alright, now let's begin. I have a couple questions here. So let's begin with this one. This is a pretty simple question. Let's see. So it wants us to describe two geometrical transformations that map this function onto this function. Alright, there are multiple ways you can do this question, but let's begin by notice how this input of the function has been translated. So to do this translation, you have to translate by the vector -1 to 0, so that the input of the function becomes theta minus -1 to become theta plus 1. So our first transformation is that to translate by the vector -1 to 0. With this, we'll achieve secant of theta minus theta plus 1. And then we need to do a vertical stretch with a scale factor of 0.5. Now, in A-level, we call it a stretch parallel to the y-axis. So let's do that. And then we need to do a stretch parallel to the y-axis with scale factors of 0.5. That will give us our answer. Notice how this question is 4 marks, even for a really simple question. So yeah. Right, now let's begin our next question. Here it's asking us to express this trigonometric expression in this form. Okay. Given the and it asks us to find the value of alpha. Okay. So first of all, let's write r cos theta minus alpha by expanding it. So this will be r times cosine alpha times cosine theta, and then that plus r times sine alpha and sine theta. Now, if we equate this to this expression right here, we'll see that the coefficient of sine theta is r sine alpha. So r sine alpha equals 24. And the coefficient of cosine theta is r cosine alpha. So r cosine alpha equals 7. Now, Now it asks us to find alpha here. To do that, we just have to divide these two expressions to get that tangent alpha equals 24 over 7, and that alpha is the inverse tangent of 24 over 7. We can quickly plug that into our calculator to get 1.287 blah blah blah. In 3 significant figures, that would be 1.29. Yeah, in 3 SF. Now, here, if it wanted us to calculate r, we could have done that by squaring these two expressions, summing them up, and then calculating the square root of that. And from that, you would get r to be equal to 25. Okay. Here it wants us to prove a trigonometric identity. So here we should begin on the one side, usually the left-hand side, and then somehow transform that into this right-hand side. And there are multiple ways to solve these kind of questions. I'm just going to go with the one I find the easiest. So we can write 2 cosec 4x plus 2 cotangent 4x. We can write, let's just expand that up first of all. So cosecant is 1 over sine. So you can write this as 2 divided by the sine of 4x. And then cotangent is cosine over sine. So this is 2 cosine 4x divided by sine 4x. If you expand this, see, sums up, we can get 2 plus 2 cosine 4x divided by sine 4x. And I'm going to factor this actually, factor the numerator here. So this is 2 times 1 plus cosine 4x divided by sine 4x. Now remember, cosine 2x is equal to 2 cos squared x minus 1. So cosine 4x is equal to 2 cos 2x squared minus 1. So if we just plug that into here, we'll get 1 plus cosine 4x will be cos 2 times cosine 2x squared. So this will be 2 times 2 cosine squared of 2x divided by, and sine of 4x, that's just 2 times sine of 2x multiplied by cosine 2x. So we get some cancellations here, the 2's cancel out. We can also cancel out a cosine 2x. So we get, what do we get? We get 2 times cosine 2x divided by sine of 2x. Now, okay, let's expand this. So remember again, we can also write cosine 2x as cosine squared x minus sine squared x. And sine, and so this will be 2 times cosine squared x minus sine squared x divided by, and sine 2x is 2 cosine x times sine x. So we can just cancel the 2's out. And then if we distribute, we'll get, well, we'll get cosine squared divided by cosine of x sine of x minus sine squared of x divided by cosine of x sine of x. So this is, what is this? This right here is cotangent of x because the cosines cancel out. And this right here is the tangent of x. And we have proved our identity. Okay, here it asks us to solve an equation, a trigonometric equation. And trigonometric equation questions are generally pretty annoying because you get a lot of solutions in them. Okay, so here there are multiple powers of trigonometric functions. Here the lowest power is secant of x, secant of 2y plus 3. So it would make sense to convert this tangent square into a secant square. Now, if you remember, tangent squared of x plus 1 equals secant squared of x. So it's time you can write tangent squared of x as secant squared of x minus 1. So our equation becomes 5 times the secant squared of 2y plus 3 minus 1 is equal to 7 minus 4 secant of 2y plus 3. If we expand, we get 5 secant squared of 2y plus 3. We get minus 5. And I'm just going to write this first. This is going to be plus 4 secant 2y plus 3. And we have a minus 5 and a minus 7. So we should get minus 12. Right? Yeah. Okay. And this is going to equal 0. Now, this is, as you can see, this is a quadratic equation in terms of secant of 2y plus 3. So we can try factoring it. Is it factorable? Yeah, it is. Okay, so I'll just try factoring it. So we can, one of the factors with this is 2y, 5 times the secant of 2y plus 3 and the secant of 2y plus 3. We can factor this as a negative 2. No, as a positive. No, hold on. As negative 6 and positive 2 like this. So we'll get 10 times the secant of secant minus 6 times secant to get plus 4 times the secant. Okay. Nice. So from this we get 2 equations. We get the equation that 5 secant of 2y plus 3 plus minus 6 multiplied by the secant of 2y plus 3 plus 2 is equal to 0. So and from this we can get 2 equations. So I'm going to begin with the second one here. So the first one, so here is our equation here is that secant of 2y plus 3 is equal to -2. So that would give us cosine of 2y plus 3 is equal to -1/2. So this is one of the simplest trigonometric equations you can get. Now remember, if you have a trigonometric equation in the form of cosine A equals cosine B, here the general solution would be that A equals B plus the period, so plus a multiple of the period, so 2 pi k, where k is an integer. Or for cosine, we can write A is equal to 2 pi minus B plus 2 pi k. This is because the cosine of B and the cosine of 2 pi minus B are equal, so we need to consider both of these cases. For sine, if you have an equation in the form sine of A equals sine of B, the equation, the general solution is going to be in the form of A equals B plus 2 pi k, or A equals pi minus B plus 2 pi k. And this is because sine of B is equal to sine of pi minus B. If you have an equation in the form tangent of A equals the tangent of B, and the general solution is going to be A is equal to B plus the period, which is pi k. And because of the period of tangent is pi. And there are no other solutions for this. Okay. So here, we need to know what value of cosine is -1/2. So cosine of 60 is 1/2. So cosine of 120 would be -1/2. Now, it asks us to, it gives us the interval in terms of radians. So we should find this in terms of radians. So this value is actually equal to then the cosine of 120 degrees, which is equal to 2 pi thirds. So now we can write the equation that 2y plus 3 is equal to 2 pi over 3 plus the period, 2 pi k. And then from this we can solve for y. We can't, so if we can write 2y is equal to 2 pi over 3 minus 3, and then we plus 2 pi k, and then we can divide by 2. So we'll get y is equal to pi over thirds minus 3/2 plus pi k. Hold on. Plus pi k. It's same. Yeah, right, okay. So now we need to find which solution this produces in this interval specifically. So we'll do that by putting pi thirds minus 3/2 into RTI. So pi thirds minus 3/2, that is negative. So that will be negative 0.45282 plus pi k. Now, to get an answer in this range, we should add 1 pi to this. So if we add a pi to this, we get that one solution of y is 2.68879, which is equal to which it asks us in 2 decimal places. So we need to give this in 2.69. There we go. In 2 decimal places. Now, for this equation, this is one of the things we can do. I'm going to label this as A. The second thing we can write is that 2y plus 3 is going to equal to 2 pi minus 2 pi thirds. That would be 6 pi minus 2 pi divided by 3. So 4 pi thirds plus 2 pi k. I'm essentially doing this right here. This is this one, and the one that we did before was this one. So now, if we solve for y, what we'll get? We'll get y is equal to, we'll get 2 pi thirds minus 3/2 plus pi k. So again, we should put that into RTI. So 2 times pi thirds minus 3/2. That will give us 0.594 395, and then that is in this range of 0 to pi, so we don't need to add a pi. So one solution we get from this in 2 decimal places, that would be 0.59 to 2 decimal places. Okay, so that was one of the solutions we got from so we got 2 solutions right now, these 2. That being said, we have another equation here. So the second equation here is this one. That would be that the secant of 2y plus 3 is equal to, what is it equal to? It's equal to 6 over 5, right? Yeah, okay. It's equal to 6 over 5. So that the cosine of 2y plus 3 is equal to 5 over 6. Now, here we knew the angle that would make, in this question, we knew the angle that would make cosine be negative 112. It's just 2 pi thirds. Here we don't. So if we write this as a cosine theta, we'll know theta. We can write theta as the inverse cosine of 5/6, which we can calculate in RTI. That would be the inverse cosine of 5/6. That would be 0.585686 radians. And then we can do arithmetic on that. So, okay. So now, what are the equations that we can write? I'm going to label this as A. Is that 2y plus 3 is equal to this theta plus 2 pi k. So from this, y would be theta minus 3 divided by 2 plus pi k. I think, yeah, right. Okay, so if we calculate theta minus 3 divided by 2, that would be negative 1.2. That's going to be negative 1.20716 plus 5k. And now this is not in the range we want, so we can add a pi to this to get. So y is going to be equal to, if you add a pi to this, we get 1.93444 something, which is equal to 1.93 to 3 decimal, like 2 decimal places. Okay, now the second solution we can get from this is that 2y plus 3 is equal to 2 pi minus theta plus 2 pi k. So from this we get that y is equal to, what is it equal to? It's equal to 2 pi minus theta minus 3 divided by 2 plus pi k. So this is going to equal to, let me put that into my calculator. So that's 2 pi minus the value of theta we calculated, which by the way is the inverse cosine of 5 over 6, minus 3 divided by 2. That gives us 1.34875 plus pi k. Now this value is in the range we want, so we can say that y equals 1.35 to 2 decimal places is a solution. So the 4 solutions, we have 4 solutions. They are 2.69, what else? 2.69, 0.59, 1.93, 1.93, and 1.35. Again, if you're unsure in these kinds of questions, you can always just plug these values in with your calculator to check if the solution is correct. Okay, let's do this question. This is another identity proving question. Can't be that bad, so we'll just expand everything again. Most of these questions are pretty much all solved by expanding or using other trigonometric identities that you know. Okay, so we can write this expression above as the sine of theta. This 1 plus cosine theta plus 1 over tangent of theta. Okay, you can write this as the sine of theta divided by 1 plus cosine theta. And that's just 1 over tangent, which is cosine theta divided by sine theta. And I'll just expand everything here. So we'll expand this by sine, so that will be sine squared theta. And then we can expand this by 1 plus cosine theta, so that will be cosine theta multiplied by 1 plus cosine theta. And all this will be divided by sine theta multiplied by 1 plus cosine theta. Okay. So this is going to equal, if we expand the upper part, the numerator, you get sine theta plus cosine squared theta plus cosine theta. Now this is just 1 plus cosine theta. And this is divided by sine of theta multiplied by 1 plus cosine theta. So the 1 plus cosine thetas cancel out, which will give us 1 plus sine of theta. Alright. Now, this question wants us to solve this equation using this identity that we've proven here. So notice how this expression right here, sine of 2x divided by 1 plus cosine of 2x plus 1 over tangent of 2x is exactly this expression right here. So we can just substitute 1 over sine of 2x. So 1 over sine of 2x for this. So we'll get 1 over sine of 2x plus also 1 over sine of 2x is equal to 4 times the sine of 2x. So, okay, 2 divided by sine of 2x is equal to 4 sine of 2x. We can cancel some 2's, and we get the equation that 1 is equal to the 2 times sine squared of 2x. Okay, so from this we can get 1/2 is equal to sine squared of 2x. And if we take the square root, we can get 2 equations from this. Let me add another page, by the way. Yeah, you can get 2 equations from this. So we'll get that sine of 2x is equal to the square root of 2 over 2, because that's the square root of 1/2. Or that the sine of 2x is equal to the negative square root of 2 over 2. Now again, this is a trigonometric equation, so we need to write this as a sine product, and the interval is given to us in degrees, so we need to find a value in degrees whose sine is equal to root 2 over 2, which is of course sine of 45 degrees. So now 2x is equal to 45 degrees, so 2x is equal to 45 degrees plus, of course, a multiple of 360 degrees. Or, I'm going to write it here, or 2x is equal to 180 minus 45 degrees, because that's what we do because sine of x is equal to sine of 180 minus x. So to get that solution, we need to write sine of 2x is equal to 135 degrees plus 360 degrees, plus a multiple of 360 degrees. So from this, we get x is equal to 22.5 degrees plus a multiple of 180k. It asks us to find a solution between 0 and 90. So from here, we get that x is equal to 22.5 degrees. From here, if we divide this by 2, we get 67.5 degrees. Of course, plus 180k, but I'm not going to write that. From this, okay, now here, you can find the angle whose sine is root 2 over 2 and negative root 2 over 2. But here, because sine is an odd function, you can just write this as negative sine of 45 degrees, because sine of 45 is root 2 over 2. And this is just equal to sine of negative 45 degrees, because sine is an odd function. So from this, we get 2x is equal to negative 45 degrees plus 360 degrees, okay? Or that 2x is equal to 180 minus negative 45 degrees, which would be 225 degrees plus 360, okay? So from this, we get x is equal to negative 22.5 degrees plus 360k. Now, notice if we add 360 to this, this wouldn't give us a solution between 0 and 90, so this is just gone. Here we get what we get. We get 112.5 degrees plus 180 degrees k. Oh, also this should be 180 degrees. Stupid. So from this, yeah, notice how this also doesn't give us any solution between 0 and 90. So we can just ignore this as well. So our two solutions are x equals 22.5 degrees and 67.5 degrees. It was asking us to solve this equation. Yes. Okay. Okay, so these are a couple A-level questions that I've solved. Now I'll be solving some just general practice questions. So let's continue. So this question asks us to find the general solution of this equation. Now notice this, there's a cotangent and there's a tangent. So we should, this is a trigonometric equation, so we should switch one of the sides to cotangent or tangent. Now I'm gonna switch this side to tangent. Remember that by subtracting because tangent of 90 minus x is equal to the cotangent of x. I'm just gonna subtract this from 90. So what we'll get 90 minus x plus 45. So we get that the tangent of 135 degrees minus x is equal to the tangent of 2x. Now, and remember in tangent, the only solution we got was to equate these and add the period. So 135 degrees minus x is equal to 2x plus the period for tangent is 180 degrees and multiply by k. So now we'll just have to, we can throw 3x here. So you can throw 3x this side. So 3x is equal to 135 minus 180 degrees k. Now here remember that k is just an arbitrary integer, so I can just switch this minus with a plus, doesn't matter. So if you divide by 3, you get that x is equal to 45 degrees plus a multiple of 60 degrees. So, and this is the general solution of this equation. Okay, here's a question about transformations from the IB book, the IB mathematics book. It's pretty simple. Let's just do it. So this is the graph of x squared, and this graph has been transformed to this graph by with a reflection and a translation, and it asks us to find the formula of this graph. So we had f of x, and it has been reflected, so that will turn into some minus f of x. Minus f of x. Now the reflection here is a reflection of the y with the x-axis. It's not with the y-axis because if you flip a parabola, the y-axis, that won't invert the direction of the parabola like this. So we have to flip this in the x direction to get this negative downwards facing parabola. Okay, then we translate by, let's say, a vector, let's say x0 and y0. So if we translate by this vector, we'll get the function negative f of x minus x0, and we add y0 to that. So okay, and remember x was x squared, f of x was x squared, so this is just equal to y minus y0 minus x minus x0 squared. Okay. Now to find these values, we can look at this point. This is the vertex of the parabola. The vertex of this parabola is the point 0, 0. So we applied these two transformations to this point 0, 0, and it goes to negative 3 and 2. If you apply a reflection by the x-axis to 0, 0, we still get 0, 0. And if we apply a translation by this vector to 0, 0, we get the point x0, y0, and that is equal to this point. So from that we get x0 equals negative 3s and y0 equals 2. So our parabola, so g of x, is equal to 2 minus x plus 3 squared. And if we open that, we get, what do we get? We get negative x squared, and then we get minus 6x and minus 9 plus 2, so that would be minus 7. Okay, and that's the formula for parabola that it was. Okay, this is a trigonometry question. Let's see. So Rodrigo wishes to find the height of this flagpole. Interesting, has a flag on it. So we'll call this height h. And okay, so basically this is just a basic geometry problem. You need to calculate h from these values given. Now there are of course many ways to do this, so I'm just going to do the simplest way I can see. So if this angle is 53 degrees, this angle would be, what would be? It would be 127 degrees, I think, right? Yeah, okay. So we can calculate this angle from that. That would be, what would it be? That would be 28 degrees, and that will be 153, I think. 155. So this angle will be 25 degrees. Now we can use the rule of sines to find the law of sines to find this side, like right here. I'm going to call it A. So here's 20 divided by sine of 25 is equal to A divided by the sine of 28 degrees. Okay. So from this we get that A is equal to 20 divided by 20 sine of 28 degrees divided by sine of 25 degrees. Now if you know A, we can calculate H. That's H is just going to equal A times the sine of 53. So H is equal to 20 sine of 28 degrees multiplied by the sine of 53 degrees divided by the sine of 25 degrees. I'm not gonna calculate this, just plug it into your calculator. I'm too lazy. Okay, this is a graphing question. It asks us to draw the graph of this function between 0 and 2 pi. Okay, so let's just solve that. So between 0 and 2 pi. Okay, let's start from 0. Now this right here, so this is a sine function that has been transformed, specifically just translated. This is just a translated sine function. It has not been stretched or in any way or reflected. So it's pretty simple. Now notice this added value is going to be the principal axis of our thing. So if you write 1, 2, and 3 like this, this is a 2. This will be the principal axis of our graph. So the wave will oscillate between 3 and 1, and will be something like this basically. And hold on. And the maximum value of sine is 1, so the maximum value of this function is 3, and the minimum is 1. So it's gonna oscillate between 3 and 1. Now the sine function, this is just, the rest is just the sine function translated by pi thirds to the right. So to do that, we'll just consider the critical points for sine, and we'll just translate it by pi thirds. So at x equals 0, sine is equal to 0. So at x equals pi thirds, this will be equal to 2. So this will be equal to 2 at x equals pi thirds, like this. And we should also calculate the y-intercept, because 0 is in our domain. So the y-intercept is a sine of negative pi thirds plus 2. That would be, this is just the sine of negative 60. So that's, what is that? That is negative root halves, I think, right? Yeah, okay. And plus 2. So that'll be just some point. What is the value of that? Let me calculate it. That is 1.1 something. 1.13. Yeah, it'll be something here. So our function will go like this. Okay, then the next important point for sine is at pi house. So at pi house, sine will be equal to 1. So we'll just translate that to the right by pi thirds. So we'll add pi house plus pi thirds to that. This is equal to, what is this equal to? This is equal to 5 pi. Oh god. 5 pi over 6. There we go. Okay. So this will take its maximum value at 5 pi over 6, which is 3. So it'll be like this. If I can draw. Oh god. Yes, okay, whatever. The next important value would be pi. At pi, it will be equal to 0. Sine will be equal to 0. So this is going to be pi plus pi thirds. This is 4 pi thirds. So it'll be here 4 pi thirds. And at that point, it will equal to. The next value would be 3 pi halves, at which sine is equal to -1. So if we add pi thirds to that, that will be, well, that'd be 9 plus 2, that's 11 pi sixths. So that's 11 pi sixths. And at that value, it will be at 1. And at 2 pi, it will have fully completed the revolution. So it will be exactly at this value right here. So it will be at 2 pi, it will be something like this. And this is the graph of our function here. Okay, now let's continue on. This our final question for today. This is a trigonometric modeling question. I mean, it's not too common, but it's fun to solve. So it says a paint spot X lies on the outer rim of this rotating wheel. The wheel has a radius 3 and it rotates anti-clockwise, so in this direction, at a constant rate, and X is seen entering the water every 4 seconds. H is the distance H is the height of this point, and it wants us to model H. Okay, so at t equals 0, X is at its highest point, so the highest point would be here, and here H would be, so that's 3 and that's 1. So at t equals 0, H is 7 meters, and this is its highest point. We can also find its minimum point. So the lowest point is here, where H is equal to 1 meters. So from this, we can calculate the amplitude and the principal axis. So the amplitude is just going to be, or I guess the principal axis is just going to be the average of these values. So it'll be 4. And the amplitude is just going to be how much it varies from this, or just the half of the difference of these. So that will be 3, right? The amplitude will be 3 because it will go between 4. It'll be 4 plus 3 and then 4 minus 3, basically. Okay, so again, the amplitude here is this A, and the principal axis is this D. So we can just write this as 3 cosine of something plus D, which is 4. Okay, to find that something, this B will be the period of our function. So the period is given here. X is seen entering the water every 4 seconds. Now, if you think about it, at some time t, X will enter water at this point. It will exit water at this point. That's not important for us. And then at 4 seconds after that, it will come back to this point and enter the water again. So the period is 4 seconds. So the period, again, remember, is calculated by 2 pi divided by the absolute value of b, where b is the coefficient of this variable in cosine. So this is equal to 4. So from this, we can say that b is equal to pi divided by 2, I think, right? Yeah, okay. You could also say negative pi halves, by the way. That is valid. But the other values would be different for that. And, I mean, this is the simplest you can take. Again, this 3 could also be a negative 3, but things will have to change for that. A couple other values would have to change for that. So I'm just going to go with the simple solution here. So if b equals pi halves, we can write this as pi halves multiplied by some t plus c. The c right here is the phase of our wave, and to calculate that, we'll just give a value. You can also take how much it has been shifted, how much the cosine has been shifted. I'm just going to give a value for this. So for example, at t equals 0, h would be 7. So at 3 cosine of pi halves t plus c, so just pi halves c plus 4 is equal to 7. So this is equal to 3. So this is equal to 1. So when is cosine equal to 1? It's at 0. So at c equals 0. Of course, you can say c equals 2 pi 2, or pi halves over pi times c divided by 2 is equal to 2 pi 2. So c can also equal 4, but that doesn't matter because of course 4 is the period. So from this we can write that h of t is equal to 3 cosine of pi halves t plus c, so just 0, t is 0, so c is 0, so this is just t, and then plus 4. That is our function. If you're not sure of your answer, you can always just test one of the points. Okay, so the second question asks us at what time t does x first enter the water. So x is rotating along this point, and when it first enters the water, it'll be at this point. So it asks us what the value of t is when x is at this point. So here the h is equal to 2 meters, as you can see. So we can just equate h of t to 2 meters. So it's 3 cosine of pi halves t plus 4 is equal to 2, so is equal to negative 2. So it's equal to negative 2 over 3. So from this, this is going to be equal to the cosine of some theta, where theta is the inverse cosine of negative 2 over 3. So we can get that from this, and get that pi halves t is equal to, it's going to be equal to theta, or it's going to plus 2 pi k, and pi halves t is going to be equal to 2 pi minus theta plus 2 pi k. So what's theta? Let's just see. Theta is the inverse cosine of negative 2/3. So let's just calculate that. That's apparently 2.3. That's apparently 2.3052. So we'll at pi halves t. So let's just solve this first equation. Pi halves t is equal to theta plus. We should also calculate actually 2 pi minus theta. So the 2 pi minus theta to see which one is smaller. So 2 pi minus theta, that, I mean, it's going to be bigger, of course. Yeah, it's 3.98266. We need to find this value. I'm pretty sure would correspond to this point where the height is also 2 meters. But it asks us to find the value where t enters the water. So we actually don't need to solve for this. And it asks us to find the first time t at which x enters the water. So we don't really need to care about the 2 pi k either. So we just need to solve for pi halves t is equal to theta. So you just need to multiply this by 2 over pi. So what is that equal to? That would equal to this multiplied by 2 over pi, which is 1.46 something y. Okay, so 1.46456, which is equal to 1.5. Let's just say to 2SF, or let's just do 3SF, whatever. 1.46. 1.46 for 3SF. So basically at time t equals 0, x will be at this position right here. All right, that's all for today. Thank you for listening. I hope you guys have a good time in your exams. and bye-bye. And don't forget to subscribe as well.